We're going to talk about comparison problems with graphs in this lesson. We use the language of comparison problems whenever we interpret or analyze any kind of graph. So all these questions are comparison problems. How many more books did Brooke check out than Jamarcus? How many fewer books did Naji check out than Tariq? How many times as many books did Selena check out than Naji? They're all comparison problems. Notice the pattern of the language. What words do you see repeated in every question? You should see the keywords in each question that you would see in comparison problems. So this is an addition comparison problem. So you'll see the keywords more or fewer. This is a multiplication comparison problem. So you see times as many or times as much. So now that we've identified that problems you create using a graph are comparison problems, let's talk about the steps to solve them. First, read the problem. Second, look for those keywords. Third, draw a comparison bar. 4, write related equations. 5, determine which equation is going to be best for you to solve to find the answer. How many more books did Brooke check out than Jamarcus? That's the problem. Number 2, look for keywords. We see the keyword more, so we know this is going to be an addition comparison problem. Number 3, draw a comparison bar. We're drawing it for addition because we identified the keyword that goes with addition comparison problems. So you'll notice I really need to pay attention to the key on my graph. This says one picture of an open book represents 5 books. So how many more books did Brooke check out than Jamarcus? Well, Brooke checked out 5, 10, 15, 20. So that's why I have 20 here. And Jamarcus checked out 15, 5, 10, 15. So I have 15 here. And I'm trying to find the difference. Remember, the difference is represented by whatever quantity is in this oval. Now I can write related equations. 15 plus b equals 20. I'm not going to use that one because I know that these two add-ins equal 20. And this is just the commutative property applied, so that's not going to be a good one to solve this problem either. Down here, I have 20 minus b equals 15. Well, again, I have an answer here. I want a place where there's not an answer. 20 minus 15 equals b. This equation is in a form that I can solve, so I'm going to use this equation to solve my addition comparison problem. You'll notice that the operation I'm going to use, though, is subtraction. Let's do a multiplication problem. The steps are the same. Read the problem, look for keywords, draw a comparison bar, write related equations, then solve the best equation. Here's our chart again, and our question is, how many times as many books did Selena check out than Naji? Times as many is our key word. That tells me it's going to be a multiplication comparison problem. So I'm going to draw my comparison bar for multiplication. I see here Naji has 5, 10 books checked out. Again, I'm going to use that key. Make sure you pay attention to that key. And Selena checked out 5, 10, 15, 20, 25, 30, 35, 40. So you'll see I have this represented in sets of 10, 10, 20, 30, 40. My next step is to write those related equations. So I can write 10 times b equals 40 or b times 10 equals 40. Neither one of those is going to be the best equation for me to use to solve because there's already an answer involved. 40 divided by b equals 10 is the inverse operation of multiplication. Again, I'm not going to use this one because there's an answer here. But I can also write 40 divided by 10 equals b. And now I have my own known quantity on one side of the equal sign, and this is going to be the equation I'm going to use. Once again, you'll notice Even though it's a multiplication comparison problem, I'm using the inverse operation of division to solve this problem.